Today we are talking about the rules of exponents. Our first rule is the rule for multiplication, the multiplication law, which says that if we multiply two terms with common bases, we keep the base and add the exponents. To illustrate this, if we had x squared times x cubed, x squared we know is x times x cubed we know is x times x times x, and notice we've got a product of 5 x's, which is equal to x to the 5th, and 2 plus 3 is equal to 5. Our second law is the division law, which says that if we have common bases, when we divide, we now subtract the exponents. To illustrate this, let's take a look at x to the 5th over x squared. This means the product of 5 x's divided by the product of 2 x's. Now notice that x divided by x is 1, and we'll have another x divided by x is 1, so those will cancel, and we're left with x times x times x, which is x cubed, and 5 minus 2 is 3. And now we're going to talk about powers. So if we have x to a power and that's raised to a power, we multiply the powers together. So if we had x squared cubed, that's x squared times x squared times x squared. And we already know from the multiplication law that when we multiply with common bases, we add those exponents. So 2 plus 2 plus 2 is equal to 6, and 2 times 3 is equal to 6. And zero exponents, if we raise a number to the 0 power, that will be equal to 1. The reason is, let's say we have x to some power divided by x to some power. Well, we know that a number divided by itself is equal to 1, but we also know that when we divide with common bases, we subtract the exponents, and x minus a is 0. So since x to the a divided by x to the a is equal to 1, and x to the a divided by x to the a is also equal to x to the 0, we can conclude that x to the 0 must be equal to 1. Now there is an exception here, and that is that 0 to the 0 is undefined. So we can raise any number to the 0 power except for 0, which might make sense if you look at this in terms of division. If the base is 0, we have a problem because we would be dividing by a 0. We'd have a 0 in the denominator. So that is one reason we can consider 0 to the 0 as undefined. So negative exponents. Negative exponents are really referring to reciprocals. So if you have a base to a negative exponent, you take the reciprocal of the base, but now with a positive power. That should be a positive a right in there. And it works the other way around. If you have your negative exponent in the denominator, you take the reciprocal of 1 over x, which is x, but now to the positive a. And now for some fractional exponents. So this would be x to the a over b, which can be written as x to the power of a, and then our index is b. So this denominator becomes our index. The numerator remains as our power. And this can be written differently. This could also be b here, x, and then the whole thing raised to the a. And to give you an example, let's say 8 to the 2/3. So that can be written as the cube root of 8 squared. So that's the cube root of 64, which is just 4. Or we can think of this as the cube root of 8 and then square it. The cube root of 8 is 2, and 2 squared is equal to 4. Notice that it's a little more manageable to take the root before using the power, because if we raise the radicand to its power, we end up with a larger number to take the root of. It's just a little easier to work with smaller numbers, so I recommend using this form instead of this. And that's it for our reminder on the rules of exponents.